Hello. I am known as Howlett. As already said, I am a member of EF for Observability Working Group. I have been working on OpenTelemetry, Erlang implementation, logging facilities in Elixir, and in this case, I am also an author of systemd integration library that I will be telling you about today. Okay, so before we start, there will be some knowledge needed. I will not explain everything about how OTP supervisors work and Elixir work and stuff like that, because we don't have time for this. We will focus mostly on operating system and higher level supervisors. So before we start, I know that systemd is a very hot topic and a lot of people have different opinions on it. It is system that is okay. It has some flaws, but in general, it is okay. But it has, as I said, flaws. So I don't want to start a flame war about whether systemd is good or bad or stuff like that. We will just be talking about how to use it, because it is currently the system supervisor and the system init in Linux world. So for the beginning, what is an init system? It is a process that is first started by your operating system. It is run as a PID1. It works on the high level of abstraction. It starts then all other processes in your applications, and it mounts all of the file systems and stuff like that. We'll be talking about what system features are interesting for us, like the socket activation. And I will show you how to use these features, and I will try to make them to do some live coding session. So in the end, so Erlang init system works like we have first process started by the virtual machine, which is called init, and it starts all the applications in our system. But what is supervising our Erlang init system? It is our Unix init system that, like I said earlier, it is first process run by your OS, run with PID1. It behaves that if this process will shut down, then whole your operating system will shut down. So it also is responsible for shutting your system down in meaningful and in safe way. As I said earlier, it starts every other process in our operating systems, and additionally in the Unixes, it is responsible for ripping zombies, which are defunct processes running by your operating systems that were orphaned by their parent process. In systemd, systemd is this system supervisor, so it does all of that. Not all init systems work that way. So in some, you have two separate processes. One is responsible for starting every other process, and init system just starts that one process. Like we have some similarities. When this process dies, then whole machine in Erlang's version, virtual machine dies, and it needs to be restarted. It is responsible for starting every other application in our operating system or Erlang system. It reads configuration, starting jobs, and listen on messages. Like, for example, we can have a message for shutting down or any other message that we have in our system. Why we even need something like that for our Erlang applications? For example, we need to have some order of application startup. For example, we need to mount file system and temp.fs before we start our application. We need to have, for example, network before we start our application. We need to configure some files and stuff like that. While Erlang is quite capable in restarting itself, a process running within the virtual machines, sometimes we end with defunct virtual machine, and we need some way to restart the application in a way that would we need to restart the application in form of defunct application. Yes. So, for example, I don't know, the application was lagging before because of it is overloaded or just bug in virtual machine. What is very handy, we have startup and shutdown hooks, which allows us, for example, to create a sysconfig for our application without involving some additional tools like configuration providers in Elixir releases, or I don't know what the relx is using for configuration, but if it isn't using anything, then you need to have some way that will fetch the configuration from external data, for example, environment, and then it need to create a sysconfig file that would be used later. It also provides us with process isolation and hardening, like something like most people use currently with Docker, but if we are using our supervisor properly, then we don't need really any Dockering or containerizer external tool for containers. It just provides us out of the box, like we have it already on our system. Like with Docker and the other process, we can limit resources, like, for example, give only a specified amount of CPU time or memory, reduce the amount of networking. So, for example, we can create an application that we will not have any access to network. We can limit access to the hard drive and files in our system. It also helps operators with monitoring state of the system. So we have information what state our application currently is in. We have an information about what processes are started by our application and stuff like that. Notification and watchdog. Watchdog is process that notifications are utility in systemd that allows us to send information about our process, what our process is currently doing. Like we can inform that our application is starting or already started and is ready for receiving any incoming messages. It allows us to provide an information that our application is currently shutting down, and the operator can wait a little, needs to wait a little bit before the application shut down, but it shows that it is currently in the progress. We can provide an information that we are reloading application and stuff like that. We also have a way to inform our application that what our application is currently doing. Watchdog is, on the other hand, is a process that is waiting for message that should come in regular times from our application. So if our application is not behaving normally, then this will skip the notification, and systemd will be responsible for starting our application for us when the timeout happen. We can also trigger forceful restart from within our application when we detected that our application is already in state that will not allow the system to heal itself. So with such a notification, then the systemd will be responsible for forcefully closing our application and restarting it again. This is the thing that is currently not implemented in my library, but in theory, we can store open file descriptors like sockets or any other connection or open files between applications restarts. So we just provide, we say to systemd, let's store it for me for a second. When I will be restarted, I will take it from you, and I will work with that one again. So with notifications, we need to somehow inform that our system is already booted and is ready for receiving any connection or working on whatever it needs. So the systemd provides a function that returns child specification for systemd for process that will send the message about the state of the system, that the system is already ready for any incoming messages. And just a second. And what is going on? The watchdog process is already handled by that, but for us, it will be managed in the background by the systemd library already. So you don't need to start any process, and it will just magically happen. The same is about the application shutting down. It will be provided, the message will be sent as soon as the systemd application will be going down. So as soon the application is received the information that it should shut down, then then the systemd will know that our application is going down, and we need to inform the operator about it. What systemd additionally provides for us is centralized log management, which is very helpful for debugging our health of our system. It provides single place to configure log dispatching for storing them in separate system. And all systems in our application sends logs to single place which we can configure for dispatch the messages somewhere else. We don't need to manage log rotation on our own. Systemd by journald will handle it for us. What is additionally helpful is that systemd will manage metadata for us, and it will be kept together with logs. So if we configure our application in a way that provides that information to systemd, then we will have information like the line and module function, the file name and stuff like that, just next to our logs, and we can filter them in our console without using any additional parsing of metadata from logs itself. As I said, we can have journal.d provide built-in log dispatching tooling, but if we need, we can of course use any external solution for storing all logs. So because as far as I know, almost every tooling out there is already integrating with journal.d. So you have single place where you can send logs, and your application will be then monitored, and you can have really centralized log management, even in distributed system. Journal.d provides 2 ways of sending logs to it. One is via standard output or standard error, and it also provides additional way to send messages via direct logging via socket that is then provided for us. While standard output and standard error messages are quite limited in their capabilities, if we log using socket, then we can have all features like multi-line logs, or provide all metadata to systemd. Logs are stored in binary format, which is not which a lot of people is not very happy about, but it is how it is. So if we are using Erlang and we want to use standard output logging, then just adding your library to your project will already provide all the information needed, as it will just fetch it will catch all the messages and translate them to whatever systemd is needing for messages to have proper log level set. If we are using Elixir, or we wanted to have a little bit more complex log system, like we want to provide metadata or have multi-line logs, then we can just add handlers that are defined in systemd, or we can configure them manually, which is described in README. The reason why I created that library in the first place is lazy startup. So with socket activation, we can start our application only when there is any request incoming. So our application, for example, this allows us to provide an application that will provide one unified system for our cloud deployment, and then let our load balancer to decide where the request should go. So, for example, we can have AWS deployment in different machines, and then the application will be started only when needed by systemd, by load balancer that will send the request to give machine on given tag or something like that. Additionally, it keeps sockets open as soon as our system starts, which means that we can receive the incoming request even before our application really started. So of course, the first request that will probably wait until the application is ready for receiving any incoming messages. But the point is that we will receive them, and we will not send user an information that the system is down. We just will keep them in the queue just until the application itself will be ready. It also keep sockets open between the application restarts. So if someone done a request before our application, before we stopped our application, for example, because we are doing release, then they will be waiting in the queue, and the socket will be the request will not be dropped, but it will be waiting for application to be ready for incoming messages again. Also, we can use sockets from which are under 1024 without running our application as a super user, which is very useful for stuff like running Elixir or Erlang application without running any additional reverse load balancer. So we can just receive our request directly on port 80 or 443 for HTTPS. How we use it? We just get the list of sockets that file descriptors that were provided for us, and we can pass it to GEN TCP or GEN UDP. Unfortunately, currently GEN SCTP is not supported because it doesn't support using a file descriptor. But I think that as soon as the new sockets module will land, then it probably will provide a way to use built-in system implementation of SCTP instead of user space implementation, which is currently used by Erlang. So I have a small demo. Over here we can see status of our application. We see that this application is dead, and it doesn't work currently. It is and here we can see logs that the application shut down some time ago. And so as soon we run any request to localhost, the application is listening on port 80. So the application is started, and it receives our incoming request with of course with and response. So we can see that the on which speed the application is running. So we can run some slow request. Again. So as we can see, we are already stopping our system where it says that it is deactivating. And even if we started some requests, it was waiting until our application was really dead. So we could still provide some additional information. We can see it even more. Just so yes, always local host. So again, we are doing our request. We are stopping our application, and we are doing request for localhost. So we see that our application is waiting until the previous application will shut down, and it will restart. And now we are receiving new process ID for our application. So we can even stop our application. So our application is deactivating, it stopped like earlier, and we can request it again, and our application will restart, providing all new information. If we restart our application, with exit error, with exit status that is not 0, so the process was shut down unsuccessfully, then our application is automatically restarted by systemd. So in this way, we can we have all the information that we need from our application without intervening, providing all information that operator may need for checking the state of our application. As we can see, all requests are logged over here with systemd journal, and that's all about this process. There is also we can also listen on many different sockets at once, like in this example where we have an ecosystem that is running on port 7, which is, by my surprise, a standardized port for ecoservice. So when we start TCP connection, then we can receive all the information from our application. We can we can also connect on UDP. Of course, as we can see, the UDP connection is connectionless. So we just, until we send any message, then any request, then it will not start the application because there is nothing received yet. So if we send, then we can see that the application started. We can also see that the application was is running as an unprivileged user, so we cannot create TCP. We cannot create connection on any restricted process directly. So we are listening on port 7, which is restricted 1, but we cannot create any new process. The implementations for as we can see, the implementation of listeners and stuff like that is quite simple. In Erlang implementation, we just see that the process is just we check for key that is described as TCP and UDP provided to the and then provide them to get TCP. In Cowboy, it is a little bit more complex. We need to provide configuration for Cowboy, provide transport options. The very important thing is that just to remember that we need to listen on init 6. So because the sockets are defined as sockets for Internet Protocol version 6, and in that way we can have all messages sent to us. What can I show additionally is logger. If we send message with warning or error level, then we can see that the messages are colored in journal output. So we have a clean and nice way to follow all messages in all log messages in our system. So questions? I think we have still 5 minutes to go.
We have at least 5 minutes. Thank you, Łukasz. Very interesting, very practical discussion here. Thanks. I have a quick question. So you mentioned at the beginning that systemd could help us also get the application prepared for operation. So assuming that my service, Elixir service, would depend on some database process like Postgres or some other processes running within the same system, can we coordinate also startup of this dependencies of other services and only report we are ready when they are actually up and running?
I can show because actually these processes have one dependency. As you can see, we can define that our process requires EPMD because by default, the systemd will the Erlang process run EPMD on their own. But in our case, we just don't want to. We also want EPMD to be managed by the systemd. So we are starting it before our application start, and with that approach, we have one EPMD that is always listening in our system, and is also managed by system supervisor. So we can add here any other dependency, for example, like you said, Postgres or RabbitMQ or whatever we need. It doesn't even need to be a network service. It can be like there are systemd defines targets. For example, we can start our application only if there is a network already running and we have network connection. We can require that some volume will be mounted when our application starts. So it provides us not only, we can, and it works both ways. We can also define that some application will depend or that some application depends on us. So we can define for example, let's say plug. So now, if we will be running a plug socket, it will require that our echo service will be running before it. So we can define the dependencies for external services services in both ways, as long as they are running on the same on the same machine.
So there's a follow-up question to this. So in Erlang, we have a supervision tree definition in one place, and there may be some quite complex dependencies between different branches of a supervision tree. And here, from what I see, we would define those requires or required by in different files, different places. So I'm just asking if you have ever had a chance to use this in a more complex production system. Does this have any issues compared to the way we define the Erlang supervision dependencies?
For sure, it is more complex. We can easily create cycles and stuff like that, but systemd is always trying to check whether our system is behaving in, let's say, reasonable way. So if there is any cycle, then we will get we will get information that, wait, there is something wrong with your configuration. Let's check it before you will try to restart your machine, because it can cause troubles. So of course it has its problems, like everything in computing, but due to complexity and legacy of applications and system deployments and stuff like that, we need to manage that complexity somehow. So that requires and require by, so we can have these relations in both ways, is a way to work around that complexity in our systems.